Alright, volumes, the disk and washer method. So if you hit this far, kudos to you, because you really pushed yourself to learn some more calculus. It's awesome. So we're talking about volumes of disks and washers, so we're going to revolve a shape around an axis. So we're given the equation, we're told that we have a region bounded by the y-axis, the x-axis, and the equation x plus 3y equals 6. So we solve it for y, because when we go around the y-axis, it's vertical, we're going to do things with respect to y. So that means we have to solve for x in terms of y. That's going to be 6 minus 3y. Okay. And we know the volume the volume of a cube is 1/3 pi r squared h. So if we revolve this way around the y-axis, that's going to make a cone just like this. Alright, and that's what's happening. So let's take a look. So if we make a volume, then we have a height here. So it's pi r squared. It's the radius, pi radius squared times this height. Pi radius squared. Okay, so in this case, x, so it's pi x squared times the height dy. Okay, so that's why we're solving x in terms of y. So if we're going to find the volume of the cone as an integral from 0 to 2, then it means we're taking the pi outside. And the radius is x, so it's pi x squared dx. Oh, I can't even see that, my bad. So since the radius is x, it's going to be pi x squared dx, pi radius squared, and then we're going to multiply times the height. Which we're going to substitute now. Pi from 0 to 2. And now in place of x, we're putting in now in terms of y, 6 minus 3y. We substituted before, 6 minus 3y. And that's radius squared dy, which goes to pi, and to go from 0 to 2. Now we have to multiply that out. Alright, so we multiply out this double distributive property. Now we have things in terms of y because we're revolving around the y-axis. It's pi radius squared and then times this thickness here to give us a three-dimensional disk. So it's going to be pi 36y. So now we're integrating. We're integrating here to here. Okay, 36y minus 18y squared because it's going to be 36x y squared over 2 minus 9y cubed over 3, which is 3y cubed, evaluated from 0 to 2, which is going to be pi, which goes 72 minus 72, you have to plug in a 2 there, plus 24. So it looks like pi times 24, which equals 24 pi. So 24 pi is the volume of that three-dimensional disk. Okay, that's what's happening there. Now here, now we're revolving around the x-axis. Okay, so we're going to have things. We're going around this way. Okay, so the formula stays the same. We try to find the volume of a disk. It's going to be the area of the disk times the width of the disk. Okay, so area is going to be pi r squared times the width of the disk, and that hasn't changed. So it's either going to be r of x or r of y. So it's either going to be in terms of x or in terms of y. So that's the only difference there. Okay. So let's take a look at this problem right here. So the axis of revolution, solve for x in terms of y. So if we're going horizontal, if we're going around the horizontal axis, then it's going to be y in terms of x. If we're going around the vertical, if we're going around the y-axis, then it's going to be x equals in terms of y. So that's the way we're going to solve that. Okay, that's what tells us. So for number 2, we have y equals negative x minus 1. So we draw that in. We know it goes from 0, 1 to 1, 0. Okay, and this is going to be y equals 1 minus x. And then, so what do they want us to do? Revolve it on the x-axis. Since we're going around the x-axis, we're going this way. This way. Okay. We're going to have y in terms of x, since we're going around the x-axis. we're going to have x's in there. Okay, so that means we're going to have volume is equal to pi times the integral pi radius squared from 0 to 1, because I want us to go from, does it say that? Oh, we know we're going from 0 to 1 because of our function there. What's the radius? What's the function? Y equals, it's 1 minus x. It's already in terms of x, dx. Okay, so we use the variable that we're revolving around. Okay. Yeah, so it's always in terms of the axis that we're revolving around. So you're solving for the opposite variable. So our volume is equal to pi times the integral from 0 to 1. Now we multiply this out because it's pi radius squared. 1 minus 2x plus x squared dx. And then we integrate that, and we have, that's going to be x cubed over 3 minus x squared plus x. Alright, and then now we put in our values from 0 to 1. And we get pi, we get 1/3 minus 1 plus 1. And so that's going to be volume is equal to pi over 3. So that's how we find that one. Okay, since we're going around the x-axis, we have to use, we're going to be in terms of x. So our volume of that disk. So it's y equals the square root of x. So you're going to have this function out here like this, approximately. And x equals 4. So we have this line coming down here. So this is going to be the point 4, 2. Alright. And so we're going around the x-axis. So it's in terms of x. So our volume is going to equal pi r squared, 0 to 4, and our radius is radical x, and we're going to square that, pi r squared, times the height, dx. And so we're going to get pi times from 0 to 4 the integral of x dx, which equals pi times x squared over 2, evaluated from 0 to 4. So it's going to be pi over 2. You can take this 2 out. That's going to be what? 4 squared minus 0 squared. So that's going to be 16 pi over 2, which equals 8 pi. Now in this example down here, we're revolving around the y-axis. It's y equals x squared. So we have y equals x squared like this. And we're going around the y-axis this way. Since we're going around the y-axis, it's going to be in terms of y. So since it's y equals x squared, it's going to be x equals radical y. We have it in both directions. So if it's x equals radical y, it's going to be 2 comma 4 and negative 2 comma 4. Because it asks us to go from 0 to 4. That's why I went there. Because we're going from y, right? So we're going around the y-axis of the height. From 0 to 4. So we're going vertically from 0 to 4 on the y-axis. It's in terms of y. So we have volume is equal to pi, the integral from 0 to 4 of radical y, because in terms of y, because we're going around the y-axis, squared dy. So you have pi times the integral of 0 to 4 y of dy. Okay, which equals pi times 1/2 y squared from 0 to 4. And so you're going to have pi times, it's going to be 16, 8 minus 0. So that's going to be 8 pi. Now number 5, we have y equals e to the x. Y equals e to the x, this, because that's the point 0, 1. And we're going from 0 to 2. So we're revolving around the x-axis, so we're going this way. That's a disk. This means there's no hole. Okay, a washer would be if there's a hole. So we're going around the x-axis like this, so it's going to be in terms of x. So that's the point 2 comma e squared. 2 comma e squared, that's the point right here. And so we already have y equals e to the x. We're going around the x-axis, so it already is in the right format. We don't have to solve it for anything else because it's already in terms of x. So we're going to the integral from 0 to 2 of e to the x squared dx, the width. So it's remember it's pi r squared, the area of the disk, times its height. It's going to be pi times, it's going to be e to the 2x. Do we integrate yet? So e to the 2x over 2. That's going to be e to the 2x with e to the 2x over 2 from 0 to 2. So it's pi, take the 2 out. And you have e to the 4th minus e to the 0. So you have pi over 2, which is e to the 4th minus 1. So that's e to the 4th over 2 minus pi over 2. Or you could leave it like this. This is fine. Okay, so this is a washer where you have a hole in the center, kind of like a washer you would use in putting your nuts and bolts together. So it's when you have an outer radius and an inner radius. So we're going to use capital R and smaller r. So let's just say you have r of x, function over here, larger radius, and you have a smaller radius right here. All that. Okay, so capital R being larger radius, smaller r being smaller radius, and we're going this way. So that's the width. And let's say we're going from A to B. Here's A, here's B, and we're revolving around the x-axis this way. So it'd be this outer radius minus the inner radius, and that would give us our hole there. All right, so r of x minus r of x. So if we have larger radius minus smaller radius, we'll have this thickness going around, revolving around the x-axis in this case. So that's what we need to do. So the note, if we're going around the x-axis, again, we're in terms of x, which means you solve for y. If you're perpendicular to the y-axis, then it means you're solving for x because it's in terms of y. Right. So in this case, let's say we have the first one, so the larger one, r of y is equal to, what do we have? We're going around the y-axis, so we need it in terms of y. So that means x is equal to radical y. Okay, and then we have the other one where x is going to equal to y squared. Okay. Now how do we know that? Because we have y equals x squared, and we have y equals the square root of x, and they come together right at 1. So actually y equals the square root of x grows faster than y equals x squared does before 1. So on the interval 0, 1. How do we know that? We're going because that's where they meet. So we're going from 0 to 1, and we're going in terms of y. So it's from 0 to 1 this way. 0 to 1. Okay? And we're going around the y-axis this way. So this is the outer radius. That's why it's squared. Our larger radius is this one, and our smaller radius is this one, away from the y-axis. This one's further, this one's shorter, so you're going to get this. That's why this one goes first. Okay, so this is y equals x squared, so it's going to be x equals radical y. So therefore, volume is equal to the pi times the integral from 0 to 1 of radical y. So it's pi r radius squared minus the other radius squared. So you have radius squared minus radius squared. So it's pi radius squared minus radius squared. That's what's happening here. And you're doing that because this one was y squared to begin with, and we're squaring that. So it's pi r. It's really pi r squared minus pi r squared. You're just taking out the pi because we have a larger radius minus a smaller radius. That's what's happening. So your volume is equal to pi integral from 0 to 1 of y minus y to the 4th. We haven't integrated yet. dy, again, because it's in terms of y, because we're going around the y-axis. So volume is equal to, it's going to be what? 1/2 y squared minus y to the 5th over 5. And we're going to evaluate from 0 to 1. So our volume is going to equal to, what's that? 1/2 minus 1/5 times pi. And so it's going to be pi, and it's going to be 3 pi over 10, or 3/10 pi. So that is an example of how to do that one.